So our next task is to identify the holes in the lattice structures. I'm going to be honest, this is going to be a little bit tricky in a video on Zoom. We're going to try our best, but we might have to look for other resources or other ways to help you visualize these holes. If you find something cool, please let me know. Okay, so there are basically three types of holes. There are the tetrahedral hole, the octahedral hole, and the cubic hole. And those hole names are based on how many nearest neighbors the hole would have. So for example, in the middle of the primitive cube, there is a hole, an empty space, that if there were an atom there, so imagine an atom, it would have 8 nearest neighbors. And so the 8 nearest neighbors, that's what makes it a cubic hole. And we can imagine if we fill that cubic hole, that's how we get the body-centered cube. Now, the body-centered cube, in the middle of the face, it has an octahedral hole. And we say it's an octahedral hole because, let's try to help you visualize this. Maybe it's easier to picture on the side here. On the face, we've got this octahedral hole where we've got 1 nearest neighbor atom here, 4 on the corners, and then 1 out here in the next unit cell. So in the middle of the face is an octahedral hole because it has a coordination number of 6. We can also imagine octahedral holes in the face-centered cube. So here along the vertex, there is an octahedral hole because it has 1, 2, 3, 4 nearest neighbors, and then 2 more out here in space. In face-centered cube, we can also see tetrahedral holes. And so the tetrahedral holes are kind of here in this empty space. Here in this empty space, where we've got 1, 2, 3, 4 atoms. Okay, so let's see those. So they're on 1, 2, 3, 4. So in this space, there is a tetrahedral hole. And in fact, in the face-centered cube, there are 8 tetrahedral holes. 1, 2, 3, 4, 5, 6, 7, 8.